Hi guys, welcome back to my YouTube channel. In this video, we are going to see about regression in machine learning. As we saw in the last video, I'm going to take the same topic and I'm going to deploy the machine learning regression code. Okay, before that, I'll be explaining that code also. Before that, regression in machine learning. What is regression? Regression is a supervised learning technique where continuous numerical values are predicted based on their independent variables or features. Okay. Like there are two types of variables. One is dependent variable and one is independent variable. Dependent variable is called as target variable because target variable is something which we are going to predict as the output. Okay. Uh, Independent variables are like which is the feature to know or to predict the target variable. Okay. Then there are types of regression. There are simple regression, multiple linear regression, polynomial regression, ridge and lasso, support vector, decision tree, random forest, etc. Okay. There are many things more than this. In my program, I had just used gradient boosting. Gradient boosting is a uh, technique which is more efficient to use in regression. It can be used in classification also. Okay. In gradient boosting, there are two types, AdaBoost and gradient boosting. AdaBoost is something different from gradient boosting, but gradient boosting is like gradient is nothing but um like what do I say? It's a concept, but boosting is like ensemble learning. What is ensemble learning is nothing but having multiple models and collecting the output of that models and giving to a big model, giving to the input as input for big model, then the output is collected from that big model, which is considered as the final output. Or in this gradient boosting, we have different idea. Like, for example, look at this picture. In this, XY is the first tree. XY is the first training data. Then it is trained to tree one. Then the first prediction is done. Okay. This first prediction is going to second tree. See the prediction output. First tree's output is given as the input for second tree. Then going there, uh, second tree's output is given to third tree. Like this, till the final tree we get, the final tree's output will be the final output. Okay. So let's go to the code. Okay. Here, same college English learning data set. Okay. I'm going to find the quiz score this time. I'm going to predict the quiz score of a particular student by getting the features from them. Okay. If you choose some features, what do I want? By getting that, I'll be telling you the quiz score, but it's a predicted one, not an actual one. Okay. So we got the target variable that is quiz score. Then other things are features. Okay. Then it is category like for encoding it is categorized. Then categorical encoder thing is fitted. Then it we do scaling here. Then we do like stacking, which is going to have both the numerical scale and categorical encoder in the same variable. Then we split the train and test data. Then we go for regression by using gradient boost regression. Okay. Then we predict. Okay. Now we are going to have the metrics to evaluate the model accuracy and things. Okay. So for the real-time prediction, I have just added some other codes, okay, to predict the quiz score. Okay, and here I have just given the extra code like I directly give sum of random inputs. Okay. Here the sample numerical input is this, and the sample categorical one is this. Okay, we have to change the input as per our convenience. Okay, so that I have taken another variable and put them into a list and column. Okay, now I encode the categorical feature, and numerical features is scaled, because categorical feature is in object type, but numerical values are numerical values. So directly we could be scaled and it could be encoded. Okay. Then we are going for the prediction. Then we done the stacking. Then we go for prediction, and the prediction for sample input is here. Prediction for sample quiz score is 93.4. Okay. This is our regression concept. Okay. I guess you got all guys understood. Thank you very much. Let me see you in the center.